Imagine a world without light. Not the romantic kind of darkness, candles on a dinner table, stars above a campfire, but real darkness, sudden darkness. The kind where the machine that keeps a patient breathing stops, where the heating system in a January night shuts off. Now imagine it happens in 90 seconds. On the night of March 13th, 1989, at precisely 2:44 in the morning, that is exactly what happened to the Canadian province of Quebec. 6 million people lost power, instantly. In less than a minute and a half, one of the most advanced electrical grids on Earth collapsed like a house of cards in a sudden wind. But here is the part that changed everything. No one had attacked it. No wire had been cut. No human hand had touched a single switch. The sun had done it, from 93 million miles away. For most of human history, the sun was simply there. Reliable, distant, warm in the summer, cold in the winter, a background presence in the theater of life. Even as we built the electrical world, the cables, the transformers, the vast networks of infrastructure that make modern civilization possible, we thought of the sun as something separate from it, above it, beyond its reach. But scientists who studied space weather had been asking a quiet, uncomfortable question for decades. What if the sun could reach us? A kind of energy that could interact with the Earth itself. The question seemed almost poetic, almost abstract, until March 1989 showed the world it was neither. It began several days earlier, far away and completely unnoticed. A region of intense magnetic activity on the sun's surface had been building, like pressure behind a sealed door. On March 9th, it finally gave way. The sun released what scientists call a coronal mass ejection, a billion-ton bubble of magnetized plasma hurled into space at millions of miles per hour. By chance, it was aimed directly at Earth. For 3 days, it traveled. On Earth, life continued as normal. People went to work, came home, went to bed. Nobody knew anything was coming. Then, in the early hours of March 13th, it arrived. When the wave struck Earth's magnetic field, it compressed and distorted it violently, triggering a geomagnetic storm. And here is where physics becomes engineering disaster. A rapidly changing magnetic field creates electrical currents in anything that conducts electricity. The Earth's crust conducts electricity. And sitting on top of it, connected through metal towers and long copper cables, was the power grid. The storm drove massive currents directly into the transmission lines, currents the system was never designed to handle. In Quebec specifically, the ancient rock beneath the province forced those currents to concentrate in the power lines above, rather than dispersing safely into the ground. At 2:44 in the morning, the first protective relay tripped. Then another, then another. In 90 seconds, the entire Hydro-Quebec network collapsed from one end to the other. 6 million people woke up in cold, dark rooms. Hospitals switched to backup generators, streets went silent. The temperature outside was well below freezing. For the engineers in the control room, those 90 seconds must have felt surreal. They watched their instruments go dark. They reached for phones to call substations and got no answer. Not because the lines were cut, but because there was no power to run them. Power was eventually restored over the following hours. By noon, most of Quebec had its lights back. But what shook scientists in the weeks that followed was not the blackout itself. It was a question nobody had properly asked before. How bad could this actually get? Because this storm, as dramatic as it was not particularly large by historical standards. In 1859, a solar storm now known as the Carrington event struck the Earth with roughly 10 times the energy. At the time, the most advanced electrical technology on the planet was the telegraph. Operators reported sparks flying from their equipment.
Some sent messages with the power lines completely disconnected. The storm's current alone was enough to carry the signal. It had been remarkable, a curiosity of nature. If that same storm arrived today, the story would be very different.
Quebec was dark for 9 hours. A Carrington-scale event today could leave parts of the world dark for months. That realization changed things. Space weather forecasting, once a quiet academic pursuit, became a serious operational priority. Satellites were repositioned to monitor the sun. Power companies began installing systems to detect incoming geomagnetic disturbances. The work is real, and it matters, but it is unfinished. The data needed to assess a storm's full impact only arrives about 15 to 30 minutes before it does. For some protective measures, that is not enough time. And there are plans to place a monitoring satellite much further from Earth, at a position that would give days of warning instead of minutes, but it is unfinished. What March 1989 gave us, more than anything, was clarity. We had built something extraordinary, a world powered by electricity, connected across continents, running hospitals and heating systems and water treatment plants and everything else that keeps modern life intact. And we had built it without fully accounting for the star at the center of our solar system. The sun is not a backdrop. It is an active, dynamic force, and we live inside its reach whether we think about it or not. The aurora that lit up the sky that night, visible as far south as Texas and Cuba, was the same energy that had just brought a province to its knees. Terrifying and beautiful at the same moment. We learned something important in March 1989. The question, as always, is whether we learned it deeply enough.